Welcome to episode 2. In this video, we're going to add the server farm to our HQ network and introduce OSPF Area 0 in the core. By the end of this episode, we'll have application and database servers living in their own VLANs. The core switches will route between user, management, and server VLANs, and OSPF will be running between Core 1 and Core 2 to keep the routing table in sync. In this episode, we're going to add a server farm to our HQ network and bring in OSPF Area 0 inside the core. We'll create one VLAN for application servers and one VLAN for database servers. The core switches will provide the default gateways for these server VLANs using SVIs and will run OSPF between Core 1 and Core 2 so that they can share all the internal routes dynamically. OSPF is a link state dynamic routing protocol that's widely used in enterprise networks. Using OSPF here means that as we add more networks later, like branches, DMZ, and so on, the routing will adjust automatically instead of us maintaining a huge list of static routes. Welcome to episode 2. Okay. If you remember previously on episode 1, okay, we have this setup, core 1, core 2, and the access switch, ACC1. In episode 2, we will set up the server switch. Okay, so we'll in the topology, we'll just add another access switch here. This one, we call it is VR dash ACC1. Server access switch, and then we will add another desktops, simulated desktops here. Let's call it SRV-app. These are server or endpoints, so SRV-DB, and server app will give IP address static 10.10.110.10. And then server DB, we will configure static IP 10.10.111.10. Okay, so we just add this one and connect like this. G00 going to core switch 1 and G01 going to core switch 2. On the core switches, core 1, this server is connected via this G0/3, same on core switch 2. So we will configure the same, just like how we add access switch 1, ACC1 to the core. So we will configure additional VLANs, the server VLANs in core 1 and core 2, and we will follow our procedure or the numbering, odd and even numberings for the VLAN numbers. So we will use this IP scheme for app server IP address. We use a VLAN 110 with a third octet 110, and for the DB database we will use VLAN 111, third octet 111. Okay, so in core 1, we will configure for VLAN 110, so 110-3. And in core, for VLAN 111, we will use 111.3 in core 1. And same in core 2 for VLAN 110, we'll use 110.2 and 111.2 for the database server. It's SRP gateway, same. We always use 111, and we always use 1.1 for each of them. So okay, so in JNS3, we'll just add this switch here with the same connection. and then the PC we just add like that, and that is for GNS3. Okay, so let's begin the configuration. So first, we will configure the this is the switch that we have added. So this is the switch that we have added. Okay, so let's see first. So show VLAN brief. So this one is empty. Show spanning tree. As you can see, the default is IEEE standard for the switch. Out of the box, it's configured as default. Okay, so show BTP status. Okay, so first we'll configure the BTP virtual trunking protocol information. Okay, so we'll copy what is in BTP information. Should be the same on all switches in your domain or in your within your switching domain. Okay, so core lab BTP domain. Okay, BTP Browning, BTP version 2. Yeah, version 2. BTP mode transparent. Okay, checking show BTP status. Okay, version 2 core lab Browning transparent. Okay, good. We'll call this RV ACC 1 means server access switch, and then let's do the spanning tree. Spanning tree mode, rapid prevalence spanning tree, check, show spanning tree. Okay, we are already in rapid prevalence spanning tree. Okay, good. Save. Okay, now we will configure the trunks. In core 1 G03, this one, okay, this one. Let's configure for trunks first. Okay, so core 1 G03. Okay, so we already done this before. Okay, switch port trunk encapsulation.q switch port mode trunk. Okay, just like in episode 1, we configured like this. Okay, same in core 2. Okay, interface gigabit. Okay, just to check. Okay, as you can see, it's not yet configured, or you can check like this. Okay, no configuration yet. Okay, switch port trunk encapsulation .1q switch port mode trunk shut down. Okay, we need to set, sorry, I forgot the native. Okay, switch port trunk native VLAN 999. Okay, 999 switch port trunk native VLAN 999. Okay, shut down already. Okay, so let's go to the server. Okay, so here, okay, so these two are trunk. We'll configure. Okay, it's already configured. Okay, so here, because there's no VLAN 999, we will create it. This one is for the native VLAN on the trunk. So VLAN 999 name. How do we call it? Show VLAN ID 999 native. Okay. So name native. We can shut this down or suspend. State suspend. This one for security. For security. We don't use VLAN 99. We only use for native VLAN. Okay, so interface range, we use range before. So 00 to 01 to configure interfaces at the same time here. 00 and 01. Okay, so switch port trunk encapsulation, that one queue, switch port mode trunk, switch port trunk native VLAN 999 shut down. Okay, so in core 1, let's check trunk information. Okay, G03 is already in trunk, or you can use show interface G03, this command to check for trunk. Okay, so it's a native VLAN 999 already. Keep trunking for all here. 10 and 110 and 999. Sorry, 99. This is for management. Okay. Okay, so here let's check show interface trunk. Okay, G03. Okay, native. Here 99. Okay. Okay, let's save. Okay, let's check here. Interface trunk. Okay, 999 native boot. Okay, so here we need to manually create the VLAN because we are on BTP transparent mode. So all VLAN should be the same in the core and here. I mean, sorry, for specific for this access switch only. So we don't need to put the other VLANs there. The users. Okay, management we can put. For now, we don't use the management VLAN. Okay, so we'll create these VLANs for the. Okay, we'll create these VLANs in the VLAN 110 and 111 in the server switch. Okay. VLAN 111 and VLAN 110. Okay, let's create there. Okay, VLAN 110. Name of server app. Okay. VLAN 111. Name is our VDB. Alright. Okay, show VLAN brief. Okay, so the VLAN is there. Server up, server DB. Okay. Show spanning tree. VLAN 110. Okay, now we are the bridge of the spanning tree. Interesting, right? So VLAN 111 is also the bridge of the spanning tree because in core 1 it's not yet there. So we'll create it there. Okay, take note that here because is in the spanning tree here. In the spanning tree, this is the only switch that has the VLAN 110, so there's no other VLAN database information or BPDO here. The sending for this VLAN, so is automatically by default is declared